Bad USBs, as they're known as, are pretty dangerous little devices. In the wrong hands, they can be used to do all kinds of things, such as install malware, and they'll work on pretty much any computer that has USB ports, which is pretty much any computer. Mac users, you haven't escaped this one. These bad USBs are keystroke injection tools. Think of them as keyboards you program in advance. Once plugged in, the bad USB will just type whatever you told it to. Seems pretty harmless, until you realize you're only a few keys away from admin privileges at any given time. These things work on the premise that computers inherently trust keyboards. Plug a keyboard in and you can use it straight away. There's no verification, there's no security protocol whatsoever. There's tons of scripts available for these guys for free online, meaning it's not hard to program and use them. In fact, they're a lot of fun if you, of course, know your limits. Kind of like heroin. I haven't never done heroin, just like make that clear. Two common bad USBs are the USB rubber ducky and the Malduino. People always ask me which is best, USB rubber ducky or Malduino, and I make the Malduino, so I am kind of biased, like don't ask me. But I'll have links for where you can get both of those in the description. But just how can you protect yourself against these devilish devices? How can you prevent them from running their scripts? Or can you even prevent someone from plugging one in the first place? Well, let's have a look right after this. Maltronics.com is your one-stop hacker hardware shop. Malduinos, Wi-Fi enabled keyloggers, and Wi-Fi deauthors all under one roof. It's run by me, so by buying anything from Maltronics.com, you're really helping the channel out. Share it with your friends, your dog, your nan, everybody. Maltronics.com, link in the description. So before we get to all the little software tips and tricks you can use to mitigate this kind of bad USB attack, it makes sense to look at physical things we can do to stop people from plugging their devices where they shouldn't. Because after all, it's just a catch-all solution and it would just fix the entire problem if it works. So I wasn't able to get some of these in time for this video, but these are Lindy USB ports blockers. The whole idea is that you put these little disposable Watsits on the end of this USB device they've got here, plug it into a computer, and then toggle the switch, and these will actually stay in the computer or laptop. Now I've got a video here of someone demonstrating this. So there's your Lindy port blocker, you put the little disposable cartridge on, it looks very user-friendly. Wow, he's having a tough time with this, isn't he? So you just plug it in your laptop or computer, toggle the switch, and hopefully it just stays in, so it's nice and flush. Perfect. Perfect solution. Well, maybe not. You see, with a small knife or paperclip, it seems you can just remove them pretty easily. So yeah, this isn't a solution to the problem. However, at conventions like DEF CON or C3, this might be a good idea just as a deterrent. If someone wants to plug something in, maybe they'll just avoid your laptop altogether and just move on to the next one. Makes sense, but for critical infrastructure, might want to look elsewhere. Our next potential fix here is called duckhunter. It's a small program that runs as a background process, and the idea is that it monitors the speed at which you're typing. So it works on the premise that these bad USBs need to go fast, like really quick. They'll type faster than any human could possibly type. When it detects those kinds of typing speeds, it just puts a block on all your keyboards and it just stops that from happening. The small disadvantage is that a few keys do get through, so depending on the length of the payload someone wants to attack you with, it could still do some damage, but let's have a look at an example. So I've got a script here that just opens WordPad and then types a load of lorem ipsum, and you'll see I'll plug this in here, and I don't think we've got duckhunter running. See, when I plug this in, give it a second because I've got a small delay on there. Let's open WordPad and just type, and I'm just going to unplug it because lorem ipsum is kind of boring. So you see a lot got through, and if that was a script that was trying to harm my computer, I'd definitely be screwed. So now I've downloaded duckhunter here, and if I go into build, now I'm just using the default one. However, it has a ton of features such as the protection policy. I've got it on normal here, such that when an attack is detected, keyboard input will just be disabled. until the attack is over. There are a few other policies here. For example, paranoid, where it will actually lock your keyboard until you put in a password, or log only, where it won't do anything whatsoever and it will just log the attack. There's a few extras, but I've just got it on default. So if I open this up, you'll notice nothing pops up. Though if we go into our task manager here, you'll notice duck hunt. There we are. So if we plug this in here, give that another run through, it may get to WordPad, or it might block keyboard input before that. See, there you go. This is all we got out of it. So of course, an RMRF would sneak under the radar, probably. But again, that's Unix and this is Windows, so we won't get that anyway. Unfortunately, it seems like this project has been abandoned, as there is a to-do list and, well, it hasn't been updated in over a year. But if someone wants to take this project up, I'm sure everyone would be grateful. So this last solution here definitely isn't a catch-all, but it's something you can do to help mitigate the worst of the worst bad USB attacks, and it's something you should do just in general to help protect your computer. For example, if you wanted a command prompt with administrator privileges, you'd need to press the Windows key, type CMD, and then hold Control-Shift-Enter, and my screen is going to go black here, but I'll take a picture of what this looks like, and left arrow key, and tap Enter for yes. And now you've got an administrator level command prompt, and that was way too easy. We just handed over admin rights with a yes/no prompt. Not the most secure of things, but we can actually change that using Regedit. So looking at the documentation here, it's under consent prompt behavior admin. So at a prompt, is it going to ask yes/no? Is it going to ask a password? Is it just going to let it through? These are the options you have. So by default, it is on option 5, which means it'll just give you a yes/no prompt, which obviously isn't very secure. So what we can do is change that to option 1, where it'll ask us for a username and password. So when a keystroke injection attack tries to gain admin privileges, it just won't know your password. It just won't have accounted for the situation where it asks your password. And at the end of the day, it probably doesn't know your password. So even if it did, it's just not going to go anywhere. It's just going to stop it in its tracks. So we can do that pretty simply. I've already got Regedit open here. But if you just type Regedit in the start menu and just open this, and then under computer on the left here, you want to go to H key local machine, software, Microsoft, scroll down a bit, Windows, current version, policies, and then just click on system. You don't have to go in here, just click on the folder here. Okay, so obviously a registry editor is pretty dangerous, so don't touch anything you're not meant to here. Don't screw around with it at all. So you'll see right near the top, consent prompt behavior admin. You want to right click that, modify, and then change value data to 1. Don't touch anything else, just press OK. And now, when you go to command prompts, Control-Shift-Enter, it's going to ask you for your password, which I obviously know my password, and there we go. But a bad USB isn't going to know your password, and it's not going to even know the computer is asking for the password, because of course it's just throwing keys into the computer, so it's just going to mess up the whole attack. So even if you're not worried about bad USB attacks, something you should probably do. Why not? So those are just some of the ways you can try and prevent yourself from becoming a bad USB victim. If you like this video, remember to hit that like button, subscribe if you haven't already, and if you want to support the channel, do go to maltronics.com. It's a site run by me, so buying anything from there really helps the channel out. So yeah, thanks for watching, and stay tuned for more hacking videos. Have a good one.